Every factory begins the same way. No walls, no roof, no machines, just an empty piece of land. So how does that empty land become a place capable of producing thousands or even millions of products every year? The answer isn't simply construction. Long before the first truck arrives carrying steel beams or concrete, engineers have already made hundreds of decisions. Where should the factory be built? How will materials move through the building? Can the ground support massive industrial machines? Will there be enough electricity, water, and transportation to keep production running day and night? Every one of those decisions will shape how efficiently the factory operates for decades. In this video, we'll follow the entire journey from a vacant piece of land to the moment the very first product rolls off the production line. Let's begin where every factory starts, with a single empty field. Step 1. Choosing the right location. An empty field may look like the perfect place to build a factory, but not every empty field can become one. In fact, choosing the wrong location can limit a factory for decades, long before the first machine is ever installed. So how do engineers decide where to build? The first requirement is transportation. Every factory depends on a constant flow of raw materials coming in and finished products going out. If trucks, trains, ships, or cargo aircraft can't reach the site efficiently, production becomes slower and more expensive. Next comes electricity. Modern factories consume enormous amounts of power. Some industrial facilities use as much electricity as a small town. Without a stable and reliable supply, production simply cannot continue. Water is another critical resource. It's used for cooling equipment, cleaning machinery, generating steam, and in some industries, even becoming part of the final product itself. Then there's the workforce. A factory needs more than a building. It needs people with the skills to operate, maintain, and repair complex machines every single day. Finally, engineers must consider local regulations, environmental requirements, and room for future expansion. Because if the factory succeeds, it may need to double its production years later. Choosing the right location isn't about finding empty land. It's about finding a place where the factory can continue growing long after the construction is finished. Step 2. Designing the factory. Once the location has been chosen, another challenge begins. Designing a factory that doesn't exist yet. You might think engineers start by drawing the walls, the roof, and the office spaces. In many cases, they don't. Instead, they begin with the product. What will the factory make? How many units must it produce every hour? What machines are required? And in what order should those machines be arranged? These questions determine how materials will move through the factory from the moment raw materials arrive to the moment the finished product is ready to leave. The goal is simple: keep everything moving. Every unnecessary turn, every extra meter of travel, and every point where materials stop or pile up wastes time, energy, and money. That's why engineers carefully design the production flow before finalizing the building itself. Only after the manufacturing process has been planned do they begin designing the structure around it. The size of the building, the height of the ceilings, the placement of loading docks, the location of storage areas, and even the width of internal roads are all influenced by how the factory is meant to operate. In other words, the building doesn't define the production line defines the building. And once that plan is complete, the real construction can finally begin.
Step 3. Preparing the ground. Before a single steel column can rise into the air, engineers have to answer one critical question. Can the ground support the factory? It may look like ordinary soil, but what's beneath the surface determines whether the building will remain stable for decades. That's why construction often begins with a geotechnical survey. Engineers drill into the ground and collect soil samples to measure its strength, composition, and its ability to support enormous loads. If the soil is too weak, it may need to be reinforced, or deep foundations may be required to transfer the building's weight to stronger layers below. Only after the ground is ready can construction begin. Crews level the site,
install drainage systems to prevent water from damaging the foundations, and pour thousands of tons of reinforced concrete. But these foundations do more than support the building. They also support the machines inside it. Many industrial machines weigh tens or even hundreds of tons. Some operate with such precision that even slight movement can affect their performance or reduce product quality. That's why the floor beneath them must be strong, level, and built to exact specification. By the time the concrete has cured, the empty field has taken its first real step toward becoming a factory. Now it's finally ready to rise above the ground. Step 4. Building the structure. With the foundations complete, construction moves upward. One by one, massive steel columns are lifted into place. They become the skeleton of the factory, supporting everything that will come later. Next come the roof beams and wall panels, transforming what was once an open construction site into an enclosed industrial building. Unlike office buildings, many factories are designed with wide open spaces. Large machines, conveyor systems, forklifts, and overhead cranes all need room to move safely and efficiently. In some factories, overhead cranes are built directly into the structure, allowing heavy equipment and materials weighing several tons to be lifted and transported across the production floor. The roof also does more than keep out the weather. It may support ventilation systems that remove heat and dust, skylights that reduce energy consumption, or solar panels that help power the facility. At this stage, the factory finally begins to look complete, but appearances can be deceiving. Right now, it's still just an empty shell. No machines, no production, no products. The systems that will bring the factory to life haven't arrived yet. Step 5. Installing the factory's lifelines. A factory may look complete from the outside, but without its internal systems, it can't produce a single product. Before the first machine arrives, engineers must install the networks that keep the entire facility running. The most obvious is electricity. Power cables are routed throughout the building to supply everything from massive industrial machines to lighting, computers, and automated control systems. But electricity is only one part of the picture. Many factories also rely on compressed air. It powers pneumatic tools, actuators, robotic equipment, and countless automated devices used throughout the production line. Water systems are installed for cooling, cleaning, fire protection, and, in some industries, as part of the manufacturing process itself. Communication networks are just as important. Modern factories connect machines, sensors, and control systems through industrial networks, allowing equipment to exchange information in real time and helping operators monitor production from a central control room. Fire detection and suppression systems are also built into the facility, protecting both workers and valuable equipment. Hidden behind the walls, beneath the floors, and above the ceiling, these systems form the factory's lifelines. Most people never see them, but without them, even the world's most advanced machines would remain silent. And now, for the first time, those machines are ready to move in. Step 6. Installing the production line. After months of planning and construction, the machines finally begin to arrive. For some factories, that means a handful of large machines. For others, it means hundreds of individual pieces of equipment, each designed to perform a specific task. But simply placing a machine on the factory floor isn't enough. Every machine must be positioned exactly where engineers planned it. Conveyors have to line up. Robotic arms must reach the correct location. Automated systems need enough space to operate safely without interfering with one another. Once the machines are in place, they're securely anchored to the floor and connected to electricity, compressed air, water, and communication network. Then comes calibration. Sensors are adjusted. Robots learn their positions. Motors are tested. Control systems are programmed to ensure every machine performs its job with the required accuracy. Finally,
Engineers integrate each machine into a single production line. Instead of operating as individual units, they now work together. A product can move automatically from one process to the next, with each machine completing its part before passing it along. For the first time, the factory is no longer just a building filled with equipment. It has become a complete manufacturing system. But one important question still remains. Will it actually work as intended?